What's poppin', dogs? Mr. Allen here with an application of compound interest. And we got the one and only Snoop Dogg and Dr. Dre. They've been saving for a bed and breakfast, right? It's their dream. They're diversifying their portfolios, right? Now, their slogan for their bed and breakfast is breakfast always hot. But that breakfast is going to be dropping on them plates like it's hot. Anyways, they invested $16,000 in an account earning 9.3% annual interest compounded continuously. All right, so we're compounding the interest continuously. The annual rate is 9.3%. When will they have $40,000 so they can start the B&B? Interesting. Well, first off, what is the formula for compounding continuously? Because we have a couple different formulas we can work with. The one we use for compound continuously is A of t equals P e to the R t, often referred to as A pert. Cool? All right. The continuously is the key here as to why we're using the base E. Otherwise, it would have said 9.3% annual interest compounded quarterly. We'd have a different formula. We'd be using the number 4 within there. Or monthly, we'd be using the number 12 within there. I'll do another video on that. This one, we're focusing on compounding continuously. So where do all these numbers go? Well, $16,000 is what they invested. That's our principal. $40,000 is what we want in the end after a certain amount of time, and 9.3% is our rate. So let's place all those numbers. I've got $40,000 is what I said for the final amount. $16,000 was our starting amount. Our rate as a decimal is 0.093. You got to move the decimal place twice, and then we have times t. Okay. So I need to solve for t. Now, there are a couple ways of doing this. You could throw this in your graph, find the intersection. I'm going to do this one algebraically and eventually with my calculator, okay? Mostly with my calculator, actually, throughout this process. So to start, I need to get e to a power by itself. I need the exponential part, its base with the exponent, on its own to solve this. So I'm going to divide by 16,000 on both sides to start here, okay? And I'll get whatever 40,000, 40 divided by 16, right? All the zeros cancel. So 40 divided by 16 is 2.5. Okay. Not a bad number to write down. Sometimes these numbers get really messy. What I would do in that case is write down a few of the decimals, but leave them in your calculator. So that way you are, able to be most accurate. Okay. YOLO. You only run once at the very end. So now I have 0.093 t. All right. Now what? Well, I've seen this done in a couple ways. So I'm going to show it in those two ways, just in case your teacher does one way or another. So some people, what they'll do is they will loop and swoop. All right, they'll rewrite it as log base e of 2.5 equals the exponent. So they have log base e of 2.5 equals my exponent of 0.093 t. Or what I've also seen some folks do is they take the natural log on both sides. Now what this does is natural log and e undo each other. This guy technically moves down as a powers of property logarithms. Anyways, it looks like this. We'd have natural log of 2.5 equals, those guys essentially, poof, they're gone, and I get 0.093 t. And you might be wondering, like, oh, those do look kind of different, but log base e is natural log, so these two are the same, okay? So however you want to do it, however your teacher has you do it, eventually you should, if you wrote it like this, eventually you should get to this point here of natural log of 2.5 equals 0.093 t. Now, what's the last thing I'm going to do here? Well, I'm going to divide by 0.093 and 0.093 on both sides, leaving me with the amount of time that this takes, which is kind of cool that you can solve for time. So I'm actually just going to type this all in at once. I can hit alpha x for a fraction. Then I'll do natural log, which is right below log. It's nice because natural log has its own key. Otherwise, I have to do math alpha math. But natural log is log base e, 2.5. And then we have 0.093. I know I forgot a parenthesis up in the numerator, but it will not matter in this case. You should get 9.8525 years. So we'll say 9.85 years. And if we were to plug that all in to the original equation here, we should get right about $40,000, right? So 16,000. Then second ln gives me the e. And then we have 0.093 times, if I put 9.85 years, should be pretty close. Yeah, pretty darn close there. A little bit off because it's a rounded number. Whereas if I did 16,000, check this out, e 0.093. And if I were to do times, arrow up and grab the full decimal, highlight it, hit enter, that copies and pastes Little hack right there if you didn't know that. Hit enter. Boom. 40,000 on the dot. So there we go, dogs. We got our answer there. 9.85 years until these guys can start their bed and breakfast if they indeed need 40,000. Otherwise, perhaps they could bring in another investor. Maybe 50 Cent got more than 50 Cent laying around. They'd be like, yo, 50, you got some money? I'd like to start a B&B. You can start it with us. And then maybe be like, let me call my boy Eminem, right? They're buddies too, right? Snoop and Dre, they go together. 50 and Eminem, maybe they pool their money and they start the B&B. And then they're, serving up breakfast like it's hot. I don't know. I don't know how the story ends, but hopefully it ends in a bed and breakfast. All right, guys. Thanks so much for watching. Have a wonderful day. And if you have any questions, pop them in the comments. Otherwise, stay dope.